Welcome, Abdul Rahman.
Good evening, ma.
Good evening. You're welcome. So let's just wait like 5 minutes, either 5 or 3 minutes. Let us see. In fact, I'll just wait 5 minutes so that more people will join. So whatever number we have, we start then. Before then, let me plug my laptop. This laptop is kind of going down. So once it's about 4 minutes time, we'll just start. Let me just see number of person that can join. Just a minute. Coming.
We are all in physics class, so it's just ending now. So we're actually coming to join you now, ma.
Okay, you are all welcome. I told the first person that joined the class, Abdurrahman, because he joined at exactly 5. So I said we'll just wait a bit for like 5 minutes to at least let some other persons join and all that. And it's exactly 5 after 5. So we're going to start. So today we are going to treat unit 5 of your course material. That's module 1, unit 5, which is on ionization energy, because we're taking it topic after topic as it is in your course material. I don't know how or well grounded you are, your O level. Somebody says, please, do I share the link to others? Of course, yeah, give them the link to join the class. I don't know. So, you must have heard about ionization energy, electronegativity, and electron affinity, and things like that. But you might have forgotten. Now, we've been talking about cations, anions, and all that. Ionization energy have to do with losing of electron. So it has to do with cations. So we define ionization energy as the energy input, the energy required, the energy used to remove the most loosely bound electron from an isolated gaseous atom. So that's why I said it has to do with cation formation, because it is when an atom loses an electron, we say it now forms an ion called cation. Meanwhile, when it gains an electron, when another atom gains an electron, it forms an anion called anion. So normally, I've been telling people about the 3 particles of an atom, that you have the protons, the neutrons, and the electrons. The protons and the neutrons, they are in the center of they are found in the center of an atom, which is the nucleus. While we know very well that the electron, we said, revolves around the nucleus. Now, the electrons are positively charged and negatively charged, while the protons are negatively charged. The other particle, the neutrons, have no charge, is neutral. But the protons in the nucleus is positively charged. The electron of an atom is attracted to the positive charge of the proton found in the nucleus. And that's what keeps it in place and all that. So for an electron to be removed from an atom of an element, energy is required. And that energy is what is known as ionization energy. Ionization, because when an atom loses electron, it will ionize. When it gains 2, it will ionize. So that's why we're using the word ionization energy. That's the energy required to remove the most loosely bound electron of an isolated gaseous atom. Why we're using gaseous atom? Because when energy is supplied, it's it will kind of, the energy that is supplied can be a form of heating or whatever, because just when the atom of an element is not supplied heat, nothing can happen. It will remain like that. But once it is supplied energy in form of heat, it can now be removed and all that. So energy is supplied to remove an electron. And the electron we're talking about is the valence electron. For every atom of an element on the periodic table, the only electrons that participate in chemical reaction is the valence electron. It's just the valence electron. And I've been telling Sarah, the valence electron is the electron in the outermost shell or the outermost orbital. Now, so that to remove this electron now, energy is supplied. So from here now, I'll begin to share my PowerPoint, having explained to us what ionization energy, what that topic in Unit 5 is. It's very, very simple. Just for you to understand that for an atom, because we're saying that atoms will either lose or gain electron in every reaction. And when it involves losing electron, you need energy to remove the electron, because the electron is normally attracted to the positive charge of the nucleus. Electron being negatively charged is now held towards the nucleus by the negative charge of the nucleus. So you need to overcome that attraction, that force of attraction. And therefore, energy will have to be supplied before you can remove that electron. So let me share my PowerPoint here. I've done something now. I have to do this again. I didn't share it colored. Okay. I hope you can hear me.
Yes, ma'am.
Yes,
All right.
ma'am.
Okay. Yes, we can hear you. Okay.
Yes, ma'am.
We can hear you loud and clear, ma'am.
All right. Thank you. So this is module 5. I've already explained our topic, ionization. Because this is the definition the way it is in your book, but I just trying to make it simpler. So we say ionization energy is the energy required to remove the least strongly bound electron from an isolated gaseous atom in the ground state. So we said this is the equation for ionization energy. M is showing an atom of an element. We're saying it's a gaseous atom. So that's why you're having that G. So when it loses electron, when it loses electron as energy is supplied to it, because it has lost electron, it will carry a positive charge. Please mute yourself. You don't want me to begin to mute all of you. I don't think I like that. I prefer that I leave it so that at any point you want to ask question, you can ask your question. So this M plus, the plus sign is showing that it has lost electron, and plus this is the electron, that E is showing the electron that it has lost. So that's the equation for ionization energy and all that. So now, you know, in the valence shell of an atom, it can have more than one electron. For example, like the group 2 elements, they have 2 electrons in their valence shell. The group 3 has 3 electrons. So you can have an atom such as all these ones I've mentioned losing more than 1 electron. So the first electron, the first energy that is supplied to remove 1 electron first, because you can't remove the 2 of them at a go, it's one by one after the other. So that's the first energy that is supplied or that is utilized to remove the first electron. It's called the first ionization energy. then whereby the second electron 2 is lost. The second energy supplied to remove the second electron is called the second ionization energy. And you will have first ionization energy, you can have second ionization, you can have third ionization energy, depending on the number of electrons that is to be lost during a chemical reaction.
Sorry, ma, I didn't get this one. Sorry, can you come again?
I said, like now, if you take, for example, the elements of the periodic table, the group 1 elements have 1 electron in their valence shell. We have already said that the only electron that participate in chemical reaction is the electrons in the valence shell. And I say valence is the outermost shell. All the other inner ones do not. So in every chemical reaction, it's only those electrons in the valence shell. Now, the group 1 elements, they only have 1 electron in their valence shell, so they can only lose 1 electron. Now you have like group 2, group 3, group 4 in that order. Group 2 have 2 electrons in their valence shell. Group 3 have 3 electrons in their valence shell because these things are grouped according to the number of electrons in their valence shell. Group 4 has 4 electrons in its valence shell. So I'm now saying, for instance, for a group 2 element, the group 2 elements normally lose, because they're electrovalent, they are electropositive, they normally lose the electrons in every chemical reaction. Remember when I was doing last week, when we were talking about, when I told you the ones that form ionic bond, that says group 1, group 2, and all that. Those ones lose electron and all that. So for a group 2 element, it normally loses 2 electrons in a chemical reaction to form ionic bond. And I said those 2 electrons will not just be removed at the same time. It's one after the other. So the first electron that will be removed is called the energy that is utilized or supplied to remove the first electron of such an atom is called the first ionization energy. Then to now remove that second electron, energy is supplied again. I told you why we have to supply energy to remove the electron. So that's second electron, the energy that is now supplied is called the second ionization energy. You can have as well the third ionization energy. I'm trying to explain just what is the course material. Somebody is raising hand, Michael. After that, Titus.
Yeah. Yes, ma. I want to ask, ma, in the what you just explained earlier, like the M will have M plus, you say the M plus simplifies, it has lost an electron, right? Then we have plus E. You say the E stands for electron that he has lost.
Yes.
Then we have open bracket G and close bracket G. What does that stand for, ma?
The J is showing you the nature of the atom, gas.
Gas, okay.
In every chemical.
And the gas could be anyone, right?
Yeah, we're just using M to represent any element. This M doesn't mean that it's a particular element. We're just using, I can use, it's just an arbitrary thing I'm using. I can use X, I can use Y, and all that. But we're just trying to signify what happens, you know, during.
My question is the G. The G, it stands for gas, right?
Gas, because when you're writing chemical reaction, you must state the nature of the element. If it's a solid, you will put S.
Okay.
If you read many textbooks, you see some will be S, some will be L, some will be G.
Yeah. Yes.
So if it's a solid, we will put S. If it's a liquid, we put small letter L. But because we're talking about gas, that's why we said
with G.
Yes, we put G. Because we define ionization energy. Let me go back to that. Ionization energy as the energy required to remove the least strongly bound electron from an isolated gaseous atom. So because we're talking about gaseous atom, that's why we're putting G. Then when we are saying isolated, means it's alone. It's alone. It is not like a molecule or a compound. It stands alone. So that's why you're not seeing this thing written as a compound, maybe MH, or any other distinct, but just to show you that it's isolated, just an atom and all that. That's why we're using the word isolated, so that you understand the definition in that your course material. So because we're talking about gaseous atom, that's why we're using G and all that. So going back, I was just okay, Titus, you can ask your question, then we can now move ahead.
Yes.
Yes. You know, you raised your hand.
Okay. Sorry, my question about the energy required to remove an ion. Yes, ma'am. The one that raised my hand, ma'am. That is, ma'am. Yes, ma'am.
So what's the question? Hello? Are you people hearing him? I can't hear him. Maybe your network is bad. Hello?
Hello,
We
ma'am.
can hear you, man.
Okay, my question, an electron. Can you hear me, ma'am?
Yes, stop. Okay, I'm hearing you now.
Okay, my question is, you talk about the energy required to remove an electron. I don't know, for the first electron, energy required to remove the first electron and the second electron, is it the same energy required?
It's not the same. It's not the same energy.
She said it's not the same. She said it earlier, it's not the same energy.
It's not the same energy. If you've been reading your course material, you will see that they told you there is not the same energy, and it is explained why. It's even in all these things, just that I'm just trying to just be teaching you before I am not just
going one after the other, yeah.
Yeah, so now remember that the electrons, the positive charge attracts it and holds it. And remember the other time when we were talking about effective nuclear charge or nuclear charge, and we said once the electron is lesser, the pull to the nucleus will be more. Now, when you remove the first electron, it means the electron is -1. It's now lesser. And I've been teaching you that the number of protons is the same thing as the number of electrons for every atom. For instance, now, let me take an atom that has an element that has atomic number 4. That should be beryllium. Is it either beryllium or boron that has atomic number 4 and all that? It means it has 4 protons. Then it means it will have 4 electrons. Now, if, for instance, the first electron is removed, it means it's now -1, meaning it has 3 electrons. Meanwhile, the proton is still 4. So you have more positive charge. More positive charge from the nucleus because the nucleus is positively charged. So you have more attraction because you have less electron. And this electron, the nuclear charge is more. So it will pull it more to the nucleus and hold it more. So it will be more difficult to remove such electron. In other words, more energy will have to be supplied than the first one that was supplied. So the first ionization energy is always less than the second ionization energy because an electron has been lost, so you now have more positive charge pulling the negative charge. So you need to supply more energy. It is there in your course material. It's even here. It says since more than one electron may be removed from a free isolated gaseous atom, the energy required for the above process is called the first ionization energy. The second energy is called the second ionization energy. And I'm showing you this. This is, I will get to where all those ones written. This is the equation for a second ionization energy. You have the first one, then you have this M2 plus E to show you that 2 energy, 2 electrons have been lost. And I wrote something that said the second ionization energy is much larger. It's what is in your course material. It's much larger than the first ionization energy. This is because in this case, an electron is being removed from a positively charged cation because that one has lost electron. It has electron. Well, it has less electron that is now pulled more by a more nuclear charge. So it's held more. So you need more energy to now remove that second electron. And the same thing when it comes to a third ionization energy. You will need more electron because now the electron, if a second one has been lost, you want to remove a third electron, it means the electron is getting less. But the nuclear charge remains like that. So keep on pulling in the more. So you will need more energy. You have to understand these things. You must understand that for an atom, it has the protons and the electrons. They are equal, but once electron is less, the proton is not lost. It's more. So it will pull it more and all that. So we now go further. We want to look at, I believe all of you understand that we want to look at the factors that affect ionization energy. We're following this in the way it is in your class material. Factors that affect ionization energy. We said, first, we have the charge on the nucleus. Second, the size of the atom. 3, how effectively the inner electrons screen the nuclear charge. Then the fourth one, the type of electron involved. I said the charge on the nucleus. The higher the effective charge felt by the electron. I explained to you what is nuclear charge and then the actual charge, which is the effective charge. And we said, I tried to explain it using maybe there are persons lined up and the torch is shining, then the one that would receive the light more is a person closer, then the person further, those other people before it will shield it. So we're now saying that the effective nuclear charge is the actual charge that gets to the valence electron, because where electron is lost now, or anything that is involved reaction is, we're talking about the valence electron. Now, the charge on the nucleus, if the effective charge or effective nuclear charge is high, that's the effective nuclear charge that gets to the electron is high, it means the electron will be pulled strongly by the nuclear charge. And it means you need to supply more, you need a higher energy to remove such an electron. So it's now invariably leads to a higher ionization energy. So the higher the effective nuclear charge, and I said effective nuclear charge is the actual charge that gets to the valence electron. So if the effective nuclear charge is high, it means a high charge is getting to the electron, and it will pull it because the electron is always pulled inwards to the nucleus. It will pull it and hold it strongly. So for you to remove such an electron, you need a higher energy input. So since we have said ionization energy is energy required to remove an electron, that means the ionization energy will be high. So what I wrote in this PowerPoint is that the higher the effective charge felt by the electron, the more will be the ionization energy and all that. Because when the positive charge of the nucleus due to the proton felt by the valence electron is high, there's a strong pull of the valence electron towards the nucleus. Hence, to remove this electron, a high energy is needed. It's just what I'll explain. So we now look at the size of the atom. When we talk about size, we're now talking about whether the size of the atom, like during our last class, we talked about atomic radius. And we now looked at the atomic radius, what will make it small or what will make it big and all that. So we were able to say that as you go across the period, you know the periodic table is divided into periods and group. Group is the horizontal rule, while the period is the vertical. The group is the vertical column. Then the horizontal rule is the period and all that. And we're able to examine some, periodic trends in terms of the group and the period. And during that, our last whatever, we looked at atomic size of a particular group. I used some examples so that to show you that in a particular period, you will see that as the atomic number increases, it doesn't affect. You see that the electron that is being added is just entering the same shell. You don't have additional shell leading to screening effect. So because there is no screening effect, you have now that the positive charge of the nucleus can get more to the valence electron and thereby pull it and hold it more, thereby reducing the size of such an atom. Meanwhile, we now looked at that when you go, like, let me use this. Now, this is for two elements. I just use two of them as example that are in the same group. Lithium, sodium, potassium, they are in the same group. So as you're going down the group, you can see that the shell is increasing. Like lithium has atomic number of 3, potassium atomic number of 19. So by the time you distribute it like this, you see that the potassium have plenty inner shells before you get to the outermost electron in the outermost shell, that last shell, that uppermost shell you're seeing. So if you look at the distance from the nucleus to the valence electron, you see that these inner electrons definitely shields this positive charge of the nucleus from getting to this valence electron. So in other words, the nucleus will not be strongly, or the positive charge of the nucleus will not strongly attract the valence electron because of those inner electrons that are screening that charge of the nucleus from getting to the valence electron. So, of course, that day we said the atomic radius will increase, unlike this other one, where you don't have much inner screening effect. So the positive charge of the nucleus gets well to the electrons and pulls it inwards. So when you now look at these two elements, which one, now I want to ask you, which one will the ionization energy be higher? I want somebody to answer.
Lithium.
So what, when you say lithium, what does it mean? The ionization will be higher or lower?
Lithium minus energy
Will be higher.
It will be higher. Yes, because it is strongly held to the nucleus compared to this one. So that's why we are talking about effective nuclear charge. And we have said effective nuclear charge is the actual charge of the nucleus of the proton that gets to the valence electron. For this one, it will get more because no screening effect. So it will be held more. So you need more energy input to move this valence electron compared to this one, where all these other inner electrons are the one experiencing this positive charge of the nucleus and blocking it from getting to the valence electron. So the valence electron will just experience less of it. So it will not be strongly held. So you can easily remove this one easier. So that's what that factor is talking about, the size of the atom and all that, because the size of the atom matters. The size of the atom and the effective nuclear charge go hand in hand and all that, because if the size of the atom is small, the effective nuclear charge will be high on valence electron and pull it more, so you need more electron. But if the size of the atom is large, the effective nuclear charge will be less on the valence electron, so you can remove that one easier. So it means if you can remove it more, it means you need less energy input, so the ionization energy will be less. While the other one, that both the size of the atom is small and the effective nuclear charge experiences will be high and pull it more. You need more energy input to remove such an electron. So therefore, by going by the definition of ionization energy, the ionization energy will be high. So those are the factors affecting. Then we now look at, say, the type of electron, whether it's sp or d, and all that. Okay, this one is just what I still use to explain the other one as per whatever. We want to look at this electron because we're trying to look at type, the type of what's that one again? The type of electron, whether it's an SPD or whatever. Because remember when we dealt with electronic configuration, we tried to say that the S is lower in energy compared to the P and the D and the F and all that, because all these things play important. It means in a particular shell, for you to remove electron, because these orbitals are found in shell, that's where you are found in the shell, and that's where it's in the orbitals you actually find the electrons. So for electron that is in the p orbital is farther. The p is farther in energy, in higher than s. So it will be more easier to remove electron from the p than the s. Another, because the s is lower in energy, so it's closer to the nucleus. That's what we're saying. But let's just look at something here, because that's the way it is in your course material. So in spite of increase in effective nuclear charge and decrease in atomic radius, the first ionization energy of boron, we want to look at this element. These elements are group 2 elements. The first one, lithium, Li. The second one, Be, beryllium. This other one, B, is boron. Then the C is carbon. The N is nitrogen. The O is oxygen. The F, fluorine. And N is neon. Neon is a gas and all that, and it's a noble gas. We are now saying, so we already have said that the way the elements of the periodic table are arranged in order of increasing atomic number. And that's actually the way it is. Lithium is atomic number 3, beryllium is atomic number 4, boron is atomic number 5, carbon atomic number 5, nitrogen, carbon atomic number 6, nitrogen atomic number 7, oxygen atomic number 8, fluorine atomic number 9, then neon atomic number 10. So they are actually in order of increasing atomic number. Now, it means that equally across the periodic table, as the atomic number is increasing, the atomic size decreases. Because the nuclear charge, the number of protons, which is the atomic number, is increasing. And like we said, across the period using this, I use just lithium, beryllium, boron, and carbon. The electron, the additional electron, because I've said that atomic number and valence electron is the same thing. So as this one is at atomic number 3 has 3 electrons, atomic number 4 it has 4 electrons, atomic number 5 it has 5 electrons, and in that order it's just the same thing. So now the additional electron is entering the same shell, the orbital in the same shell and all that. So there's no anything screening it. There's no additional shell to be bringing about screening effect of the inner electrons. So it now means the nuclear charge is increasing. The electron too, the negative charge is increasing. So they are attracting themselves strongly. So as these things, as both of them are increasing and the attraction is getting stronger, the atomic radius, the size of the atom will be decreasing. So it means if it's decreasing as you go across, if the atomic size is decreasing as you go across the periodic table, it means that the electron is now being held more and more across the period as the atomic number is held closer, held more tightly to the nucleus. Then it means ionization energy will increase across the period. And that's the way it is actually. Across the period, when we talk about periodic trend, that's what is in your course matter. That across the period, ionization energy increases. But there's a but. It doesn't happen like that for some elements. Because of that other factor we're talking about, the type of electron involved and all that. So we're going to look at, we use now beryllium. Here, we said the first ionization energy of boron, B, is 801 kilojoule per mole. Then that of beryllium is 900 kilojoule per mole. Ordinarily, if you look at what I showed you here, beryllium comes before boron. So if we're saying that as across the period, ionization energy increases because the atomic size is decreasing, so you need more electron to remove any whatever. It means that boron should have a higher ionization energy than beryllium. But we're saying that it is not so. Also, when it comes to nitrogen and oxygen, oxygen should have a higher ionization energy than nitrogen, but it is not so. So we want to check why is it not so. That's why we're saying that in spite of increase in effective nuclear charge and decrease in atomic radius, the first ionization energy of boron is 801 kilojoule per mole. Then that of beryllium, which is atomic, which is Onyebuchi Princess. Please just mute yourself. What is wrong with you? Okay. Then we said, then that of beryllium is now 900 kilojoule per mole. It shouldn't have been like that. So I want to look at why is it so. So for beryllium, beryllium has atomic number 4. So this is electronic configuration. This is the way so it means it has 4 electrons and it's distributed this way. Then for boron, one thing about this kind of configuration, these electrons, they are stable because this s orbital is completely filled up. For every atom that has a filled electronic configuration, it makes the atom stable. And any atom that is stable is difficult to remove electrons from it. Remember, I told you people that why every chemical reaction happens is because all those elements of the periodic table are trying to attain stability. Then, we said whereas in boron, the electron is removed from the singly occupied 2p subshell. This is for boron. And the electronic boron is atomic number 5. So it has 5 electrons distributed this way and all that. So who is trying to record what? You don't do this kind of a thing when we're doing it. I said that these anomalies in the trend in ionization energy can be explained by the electronic structures of this element. In the case of beryllium, the electron is removed from the filled s subshell, which is what I've showed you there. I said, if you remember, the 2p subshell is higher in energy than the 2s. So the 2p electron of boron is more easily removed because for this one, for this boron, this electron here, this valence electron, because this is the valence electron, it is farther. Even though they are both, when you look at them, they are both, these 2s and 2p are in the same shell, which is the second shell, and that is the L shell going from the nucleus. So, though they are in the same shell, this shell have two orbitals. The second energy level from the nucleus has two orbitals, the s and the p orbital. Remember when I taught you that? So this electronic configuration, when this thing is being distributed, you have the two electrons entering the first shell, and we said that first shell has one orbital. Then the three remaining electrons will enter the second shell, and that second shell has two orbitals, the s and the p orbital. So you have two entering the s orbital, is completely filled up. Then the remaining one goes to this one, and this p orbital now is higher in energy to the s. So this one electron, this first ionization energy, this one electron is farther away from the nucleus. So it will be removed easier than this beryllium. The valence electron is in the s orbital. So the first electron to be removed is closer to the nucleus. So it will not, more energy will be needed to remove this first electron from this orbital that is closer to the nucleus than for this boron. Is the first electron to be removed that is farther away because it's in the p orbital. That's what it's trying to explain to you, that the type of orbital too matters, because the orbitals are in order of increasing energy level 2. The s orbital, as I told you the other time, is lower in energy. Then the p orbital is higher than it. Then the d orbital is higher than the p orbital. Then the d orbital, the f orbital is higher than the d, because we have spdf. So that all the things we have learned, you have to learn how to put them together. You don't forget, even when we did electronic configuration, you think that is it. You will still be seeing these orbitals, seeing how they affect the properties of atoms and some periodic properties of atoms. So that's what that other factor, that fourth factor is saying, that the type of orbital equally affects ionization energy. So in summary, for an orbital that is closer, that is lower in energy, it will be closer to the nucleus. So when you have an electron there, it will be, because it's closer to the nucleus, it will be held more. Then you need more energy to remove such electron from such orbital. Then the one that is high energy will be farther away. So the lesser energy, when you compare the one that is closer and the one that is farther, you will need lesser energy to remove such energy. That's why you find this anomaly when it comes that ordinarily the periodic trend is that as atomic number is increasing across the period, because atomic number is the same thing as proton, it means the nuclear charge is increasing and all that. So the electron too is increasing. Then the attractive force between the neutron, between the positive charge of the nucleus and the negative charge of the electron would equally increase, such that for you to now remove an electron from the valence shell, you need more energy input. So ionization energy increases. But we are now saying it's like that, but you now observe some anomalies because of the orbital where the electron is. The electron of the valence shell, that's the orbital of the valence shell where the electron is, because when we're looking at the electronic configuration, we said, that's why I started telling you about the principal quantum number, the shells. Then inside the shells, you have the orbitals, and that each shell has a number of orbitals that is in it, and the number of electrons that will be in a particular shell and in a particular orbital and all that. I taught you how to calculate all those things. So that's why you're seeing ordinarily, as it is in your course material, I'm just trying to explain it to you, that beryllium should have a lesser ionization energy compared to boron, because boron has a higher atomic number. So the ionization energy should be higher. But we're saying it is not so, that the ionization energy of this beryllium is higher compared to this one. And we're now trying to explain so that because that the valence electron for beryllium is in the s orbital. So when you want to remove electron from this s orbital, that is what I showed you here in the s orbital. When you now want to remove electron from the s orbital that is lower in energy, so as it is lower in energy, it is closer to the nucleus. So the nucleus will attract that valence electron more. So you need a higher energy to remove that electron, compared to boron, whereby the valence electron is in the p orbital. And this p orbital is farther from the nucleus. So the energy will be lesser compared to that one. Even though if you look at now, both of them are in the same shell. The second shell from the nucleus, look at this one too, 2s2p, they are in the second energy level or the second shell. But because of that beryllium is atomic number 5, so after this one, this one is 4, it goes into 1s2, 2s2, you have this. Then that additional one to make this one 5 goes into a p orbital in that same second energy, in that second shell. Let me be using shell. Now, because this valence electron is in the p orbital, which is farther from the nucleus, the ionization energy becomes less. The same thing too when you look at oxygen and nitrogen. Because when you arrange them, nitrogen comes before oxygen. The atomic number is 7, but for nitrogen, but for oxygen, the atomic number is 8. So ordinarily, ionization energy of oxygen should be higher if you follow the way the periodic trend should be, but it is not so. That of nitrogen is more, as it is in your textbook, and we're looking at it. We're looking at why is it so. For these ones now, the two of them have their valence electron in the p orbital. And we're saying, I said, let me come to that of nitrogen. I said, when we come to nitrogen, we will find out that we have a half-filled 2p subshell electronic configuration. While in oxygen, the 2p subshell is occupied by 4 electrons as shown in the electronic configuration of both nitrogen and oxygen. When I said the 4th electron in this 2p subshell is in an orbital already occupied by another electron. So it experiences considerable repulsion. So I now go back, having made my point. These ones are single. Remember the order of filling. You first of all feel single before you now begin to. So for this one that is 7, when it comes to this P, single, this one is 8. That additional one, after single, you now begin to pair and all that. So we're not saying for this nitrogen, because of this pairing here, there's some electronic repulsion. And when there's electronic repulsion, it will expand the size of the orbital and all that. So now making this orbital, the whole of the two orbitals, to be more farther away from the nucleus compared to this one. So with that one, the nuclear charge will not be much on these two orbitals the way it is on this one. So if it is like that, then a lesser energy is needed here than for this 2p orbital of the nitrogen. So in that case, it will now bring about a lesser ionization energy for the oxygen compared to nitrogen. That's why they're talking about the nature of the orbital and all that. So with that, okay, I think the last thing here is about periodic trends in ionization energy as it is in your course material. We said down a group, the number of energy level increase and the distance between the nucleus and the valence electron increases. The increased distance weakens the nuclear attraction to the outermost electron, and it's easier to remove an electron. If the attraction is not much, we have said it will be easier to remove an electron. And this is, I brought back this that I used to teach you the other time. This element, lithium, sodium, potassium, they are in group 1. They are the first 3 members of group 1. And as you can see, as you are going down the group, you have additional electrons are going into additional shells, thereby bringing about in these inner electrons that will screen the valence electron, now making that the valence electron will not be tightly held to the nucleus. And if it is so, it means as you're going down, as these shells are increasing, the valence electron is getting further away from the nuclear charge. Then as you're going down the group, then it means the energy needed to remove the valence electron keep on becoming less. And we're saying that this energy needed to remove the valence electron is ionization energy. So it means it becomes less. So down the group, in summary, ionization energy decreases. But across the period, ionization energy increases because the electrons are entering the same shell. So there's no screening of inner electron. So there's strong attraction between the nucleus and the electron. So more energy is needed, except for those other ones, those other elements where we now looked at the type of orbital. But it is still increasing across the period, while down the group generally it decreases. So that's the trend in ionization energy. So these are just summary of what is in your course material. So any question before we call it a day here? Yes, Olusanya Timilehi.
Good evening, ma.
Hello. Good evening, welcome.
Thanks for the lecture. I really appreciate it very well, ma. So welcome. I have 2 questions.
Okay.
You said something before you closed it. You said in every complete or stable atom, said it is always difficult to remove electron. Please, I want you to explain again. And my second question is that I don't hear the last word that you said. I don't hear it very well. You said across the period, the electron. So I want
to. Okay, let me begin with that. Across the period.
Okay, ma.
Ionization energy increases. Then down the group.
Yes, ma.
Energy decreases. And I've explained why. You know,
Yes,
this
ma'am.
is not just about saying it, but why is it so? And all that.
Yes, ma'am.
And for the first one,
Yes,
yeah,
ma'am.
remember I've been saying that for every all the elements in the periodic table react,
Yes,
there are some that are unreactive, totally unreactive, like the noble gases.
yes, ma'am.
That's the group 18 elements. They are
Yes,
not reactive, and we normally use them as an innate material for things. When you are looking for something that will not react, that will just remain like that, it's those group 18. It's because they have a filled orbital and a filled shell and all that. So that makes them stable. So, because I said for all the elements on the periodic table, what makes them to keep on reacting is to attain stability, to attain what we call the doublet state or the octet state. The octet state means their valence shell will be filled up with the right number of electrons. The doublet state means that those ones that their valence shell or should be 2, should have it complete as 2 and all that. So, but leave that one. I even talk about stability or whatever. Just look at what is making ionization energy increase, what is making ionization energy decrease. And as we say, across the period, ionization energy increases. So we now came to some element, beryllium and boron, nitrogen and oxygen. We now saw there was some anomalies.
Yes, ma'am.
So we now try to explain using the type of orbital where the electron is to explain it. But generally, the general trend of what we call periodic trend is that across the period, ionization energy increases. We have explained why, we have seen it. But down the group, ionization energy will decrease.
Yes, ma'am. Thank you, ma'am.
And for every, I want to teach you people something, not just for this course, in any course you're doing. First and foremost, that definition, look at that definition. So when you understand that definition, you'll be able to apply it. Like now, we're talking about ionization energy. Once you understand the meaning, that this is the energy required to remove an electron. So you know when we're saying that ionization energy increases or whatever, it means the energy required to remove electron is either increasing or decreasing, because you have to understand it, then it's happy to know why it's happening like that. Any other question?
Hello, ma.
No.
Yes.
So is the slide going to
You said?
to us later, ma?
I didn't hear you.
Is the slide going to be made available for us?
Yes.
The slide, is it going to be made available for us?
I heard the ones you did the other time. If you go to the e-learn platform,
the PowerPoint, is it going to be made available for us?
Available
later,
to, how is it going to be made available to you? You only just see this,
All right,
the recording
you,
of this. Yes. Any other question?
No, ma, for now.
Okay. I hope people are participating in the practicals that have commenced.
Yes, ma'am.
But there was a problem, no. There was a problem, serious one.
Where is what study center is that?
VIU, Mat 101. They put 4 p.m. All of a sudden, we were to prepare towards 4 p.m. Some people were there, they called us that they started the practical since around 9 in the morning. And we couldn't meet up. But suddenly, a news came up today again that they said they might bring up the practical to those that were not present on Monday, that we should come, according to what I heard.
Okay, see what you do. You see, for Lagos, I believe what you're using is the timetable forwarded to you by your study center.
Yes, from the portal, yes.
But for those of you in Lagos, you know, Lagos is where they have the highest number of student population.
Okay.
And again, the lab, if they begin to use that timetable the way it is for your population, because I've come there to conduct practicals and everything. I'm even going to come there for monitoring. So you see me. So if they use that slab all those lab. It means, in fact, for them to have effective practical for you people, it means they will have to use the whole entire building on that VI. So because it will not be possible, that's why they now change the timetable. They make it, I think, a course per day and all that for some of it. For like I'm talking about physics, chemistry, biology, and all that. So
but they
what
didn't
you
pass
will
this
do,
information.
so what I'm trying to tell you is that as you have gone there, try and ask them the timetable they are using. The timetable is kind of different from the general one given to other people because of the population.
No wonder.
Of Lagos. It's even applicable to Abuja here. So there's a different timetable for Lagos, but somebody is in charge there. When you go there, they will give you the timetable. So please, all of you that are in this class, that are your practical center is that BI, try and know the timetable that they are using there. It's not the same one that is general to other places.
Thanks for the information. I really appreciate it.
But
you're welcome.
when I went to meet the lecturer at the end of everything, the woman told us that we will have this practical again Monday, Tuesday, and we must be there as early as possible. That she have been in that school before since 7-something a.m.
Oh, which practical is that? Is it chemistry 191? 192?
Math 101, no.
Math 101, a practical course.
Pass the information to my colleagues, man.
Math 101 is not a practical course.
That is what they did, though. That's what they brought up. Math 101. Also shocking.
Practical.
What's practical about it?
Yeah.
Okay, listen to me.
Please.
What is practical about it? They are going to teach you what they call equation editor. You know, when you're writing your exams and all those things, you need to use this computer software to write and all that.
Okay.
It's even to your advantage and you're not paying for it. You should be happy.
Okay, it's a teaching class, not a test.
It's not practical. Is it a test? Practical is for you to go and do practicals. This is science. Are you not in faculty of sciences? So everybody in faculty of sciences will do practicals. So when you go, they are just going to teach you how to use laptop, some function of the laptop of computer.
Okay.
Equation editor to write and all that. You don't know it. So it's to your own advantage. Even the computer you're learning, it's to your own advantage. People pay highly for what you're going to learn. It's just to help.
So what about those that don't have a computer, those that does not have laptop?
They will give you computer there.
Okay.
The school will
because
take
I was
care
told
of
that.
you.
That's not what I heard.
It's the next thing that the school that is working.
That what?
She said we should come with our system next term, like next practical that we are with the system.
Anyway, I don't know because basically they are supposed to provide, they're supposed to take you people to the computer room where you write your exams and you use those laptops there. That's what I believe.
That's the best way it should be done.
Yeah, that's the way it's designed to be. You're supposed to use, because the way the school designed it, that you should use.
No, because everyone cannot have a laptop. It's not possible.
The laptop there. They will provide you. You use the laptop there. Because that's the way the faculty have arranged it. Yes, somebody Olajide is raising his hand.
Yes, good evening, ma'am.
Good evening, you're welcome.
Yeah, thank you for the lecture.
You're welcome.
Yeah, ma'am, I want to ask, ma'am, according to the Math 101 my colleague just asked about, you know, the practical is in batches. The first one started today, which is 3rd to 16th October, and the second batch is 17th to 31, because Math 101 is on that batch too.
Okay.
So does it mean that if you have done it in this first batch, it doesn't matter? We don't have to do it again, the second batch?
You wouldn't know now.
You know what I would advise you? When you go for that practical, ask them. Let them, you know me, I'm in chemistry, so I know.
Yes, she wouldn't know, yes.
Okay, if it's
chemistry, what I would advise you, when you go, ask them, they will explain to you, because you're not expected to do it for 1 month. It's just for a period. Each of those practicals is just for a period of 2 weeks. So if they say it's in batches, it means maybe those that have done it for 2 weeks should not come again. It's just for 2 weeks.
All right.
Okay, so it's not a 1 day something.
Never can tell. Never can tell. Check your timetable. Let's go look for the real timetable. Finish what you said.
It's not a 1 day. Now, let me tell you, they started with the 192s, like CHM 192, Physics 192, Bio 192. So each of those courses are for 2 weeks. 2 weeks. Then even those computer and all those they are for 2 weeks. Then after 2 weeks, the next 2 weeks is for those offering 190, like for example, chemistry 191, biology 191, physics 191. They are not the same courses. For this now, they are starting with the 192s. So
after you just explained what I was asking. You just explained it. Because there's March 101 in the batch 1 too. You just explained it quite all right now. Because there are 2 different courses.
Since there are 2 different courses, it's just each of them is just for 2 weeks, 2 weeks, not for a period of 1 month. So, like now, some of you, what you're doing now is it not 191 you're doing now? Is it 192?
You're doing 191.
It's 191.
191. So it's
191 is for
so your 191 is going to start after
on the 16th.
On the 16th. So the people that are doing 192 now, those that are registered for 190, those people that are in second semester already.
Yes, yeah.
Those that are in second semester already, they are the people because 192, all the 192s are second semester courses. So it's for those of you that are just coming, it is 191 you're doing, and that one will start at the end of
first semester.
When this so it's not for you now.
Thank you.
Thank
you for the clarity, man.
Yeah, so once it is, you're welcome. So once it is that time, make sure you attend, because that is what they are going to use to score you.
God bless you.
Attendance.
Attendance and the practical, not just attendance. You do the practical, they will mark it and they will bring the score. That's what you're going to use. So I'm telling you now, it's compulsory. If you don't do it, you will not have a complete result. Once you have once you don't have a complete result, that's automatic F. So you better attend it.
Wow.
I have a question.
Yes.
Example for your course now, the practical for chemistry 191. Are we to go for all the days, or do we go just once? Are we good?
You will do all the practical courses now.
As required.
I mean, for chemistry now, are we going to attend for it because it appears multiple times over the week? Are we going to go for all?
Yes, because they are different topics. It's not the same topic. Where have you carried your 191 practical, your 191 course material? Even the manual is online. When you check it, you will see the number of experiments that are there. So you're meant to do all of them, and you cannot do all of them. Who is that one that's making that noise? You can't do all of them in a day. So it's one after the other. That's why it's for a period of 2 weeks.
Mommy, sorry, ma'am. A better question is this, ma. Are you with me?
I'm listening.
Please, ma. When I was going through my course material, I saw where they mentioned a safety glass regarding those chemicals, like your course right now, chemistry 101. Are we advisable to go get these safety glasses?
Oh well, yes. If it is before, they used to supply, but I don't know if they have, because before we used to supply students with safety glasses. But you have to have your lab coat.
Okay, yeah, I have that already.
You have to have your lab coat. The safety glass we used to supply the students. I don't know if the ones we have are still there. Who is that one? Osho Sadimat making this kind of
take a bus.
Yes, I can understand. So I want to believe we're done. No other question, so that we can call it a day. So in the absence of no other questions, because we've answered every question we should ask, who is this? Moreni.
Keji.
Okay, ask your question. You just raise up your hand. Yeah, you want to ask a question?
Hello, ma.
Yeah.
Hello, ma. Please, I don't know if you have idea about Ibadan Study Center, because my study center is Ibadan and I'm in Ibadan. I don't know where they are going to do their practical.
There's no Ibadan this thing. Didn't they from the notification? They told you for southwest. The practical center is Oshogbo, Abeokuta, and Lagos. So you choose the place you want to go, the place that is nearest to you. Now, since you're in Ibadan, where among these places is closer to you? Is it Abeokuta? Is it Oshogbo? Is it Lagos?
Okay, ma, thank you.
So you have to choose where is closer to you and go. If you check in that timetable, or I mean in the memo sent,
okay, ma,
you have, Nigeria has 6 geopolitical zones. So no, we are not coming to you. Do you know how many study centers we have? 130 study centers. Is that what you would do? Do you know how expensive it is? It can't be done. So it's done based on geopolitical zone. So now for Southwest, it is Lagos, Oshogbo, and Abeokuta. For South, it's Uyo and Benin. So those in the South, you check where it's closer to you. Is it Uyo? Is it Benin? For Southeast, it's Enugu and Owerri. So if you are from that place, you check where it's closer to you. Then for North Central, for North, you have North Central. North Central is Makurdi and Abuja. So if you're within the North Central, check where it is closer to you. Even though Kwara is in North Central, but we know that Kwara is closer to Oshogbo than coming to Abuja or Makurdi. So it's better for students from Ilorin and all those places to go to Oshogbo. Is closer to them and all that. Then for Northwest, you have Kano and Sokoto. So if you're in the Northwest, check whether Kano is closer to you or Sokoto and go there. Then if you're from Northeast, you have Bauchi and Yola. So if you're from the Northeast, check whether Bauchi is closer to you or Yola is closer to you. So you go to study centers there. That's where they are having it. And they have started for those in second semester. All right. I think I've answered all your questions. So who is this one, Roofs? Ask your question. It's getting dark. So that we can call it a day.
Yeah, good evening, ma.
Good evening, you're welcome.
Hello. Yeah, thank you, ma. I said, like me, that I'm in Kano. I'm not very sorry. That is, I'm to go to Kano. So is it, Kano, they get like 3 study centers there. Is it any study center that if I go there, I can?
No, it's not
enter
any
to
study center. What's the name of that? Okay, maybe during the next class, I will find out the particular name of that study center in Kano that you go through.
Okay.
The one in Kano City
you, ma.
itself. I've forgotten the name of that area because I know I've been there how many times. So I would maybe during the next class I will get the name of that particular area.
That is the one in Tokarawa.
Mention another place. Maybe it's mention the 3 places. Maybe when the next class I'll find out the particular one in that.
Yeah, I think
for those
they
in
have
that
one in. Okay.
Okay. So all right. I think we've answered everything. So see you.
I said, like, they have.
They have what?
Yeah, I said they have in Tokarawa. They have one in Tokarawa, at Tokarawa, and they have in Bachirawa, and they have in Faiki. These are the 3 that I know that are in Kano.
Okay, what will happen that by the time we come for the next class, I'll find out the particular name of that place. I myself, I know the place. It's just that I don't know the name of the place. Whenever I go, I just know where I'm going to, but the name, I can't remember. So I'll find out. If you know any of them where they built lab, that study center where they built a lab, where they have lab, that's where it is. So I don't know the name of that area where that one is, but maybe by the time we come for the next class, I'll be able to tell you. All right. Let's now I don't even know, because I wanted to say maybe we'll have extra class on Saturday. I don't think I have that kind of energy and all that. If I'll be chance on Saturday to teach you, I will notify you.
Okay, ma'am.
I will let you know and all that.
Okay,
All right. Good night.
Thank you, ma'am.
Thank you, ma'am. Have a lovely night.
You too. You're welcome.
Thank you.